Hello, good morning.
Morning.
How are you? Lucas, thank you for your camera. Thank you.
Welcome.
Okay.
Good morning.
Um, sorry, more people waiting. Very good. A lot of people here today. Very good. Happy to see all of you. Nice. Adriana, Alexander, Benjamín, David, Tina, Elsa, Florian, Laura, Liva, Luca, Milos, Mirna y Natalia. Natalia y Panagiota. Very good. Nice. Today we have a very important lesson. We will talk about unification. This is a very important concept. What about your 3 days last week? Was everything okay?
Yes, thank you.
Okay, nice. Nice. You have time to travel? You have the opportunity to travel to any place or not?
We are allowed to be only in the province of Huelva.
Yeah. You have time to visit some place in Huelva?
Yes, to Aracena and some.
Oh, nice. A lovely place. Perfect. Nice. You have to take, this is your task, try to discover at the same time to learn things in academic things. This is your great opportunity to discover Spain. So um, you have to your time. Okay, nice, perfect. Let's go. Do you remember last thing we saw in last session? That's someone who has any question about last session? What we did? Do you remember? Everyone knows about the YouTube videos. You know what? We have a YouTube channel where I upload after each session. I upload the video, and we have a lot of questions. I want to share my screen. I'm going to share my screen to you because there are people very active in the YouTube channel English with many questions. That's very nice. There are some questions here from Leo, and that's super nice because he shared ideas. He write Felix. He writes some examples. He has very good this information, and here he said it's a big topic because there are some new concepts we need to understand. With another examples is unification. This is what exactly we are going to see now. I am continue translating the document. I'm gonna show you last version. Oh, is this one? Pum, pum, pum. Oh. Okay, I have to share this document to you. This is the last version. I am translating every day a little part of this document, and um, everyone have access to the GitHub. Do you have access to this repository in GitHub? This is the place where I upload after each session the exercises. I can try to upload here the document. You know how to access here? I'm gonna share this link in the chat, and you can access to this link to this web page. Give me 1 second. Okay, in this link I just shared to you, you can access to this repository in GitHub where I'm going to upload every day the exercises. Here, I will try to upload here the file. Let me 1 second. Add file, upload file. I'm gonna upload here the files. This new version. Okay. And now, if you access to this link, you can download this version. It's a previous. It's not full translate, but you have here the part of this document we need to continue. Okay. So let's go to take a look a little. We was last day. Do you remember that? What is a horn clause? Can you tell me what that means? Can you tell me what is the horn clause? Do you remember that? What's that? And what is the reason why we use only horn clauses in our programs? Do you remember what that means?
I think it's when there are different antecedents for one consequence.
Yeah, several terms in antecedent. That's perfect. Separate by what? Separate by symbol or operator. Several terms in antecedent separate by Luca.
Separated by operators like and or.
No. But
No?
only one type of operator.
It's only and.
Exactly. Separate
Right,
only
right.
by and. Okay, that's very important. And you have to remember that when we write, I want to share my screen. Just okay. I'm gonna write here. Remember that. Remember when we have some, for example, term one and term two and term three. If that is true, then only one term inconsequent. For example, sorry, term three, and term four, whatever. Several terms separate by and only one inconsequent. And for example, that is horn close. Okay, that is was one of the concepts we was see last day. And for example, if I write only one term, therefore that is called fact. Sorry, that means it's a simple. Okay, this is a rule. This is a rule, logic rule, and this is a okay. So we'll the at the end is one, so zero or more. In this case, we are zero terms in antecedent at only this consequent. That means at the end, that means a simple fact. So will be zero or more terms in antecedent separate by and only one term in consequent. Okay, this is the definition of zero. Definition of horn clause. Okay, that is one of the last. And why? Who can tell me why we use only this type of rules in our programs? Who remember what is the reason why we only use this type of rules? That is a subset of logic, because in logic we can express more things. What is the reason why we only use horn clauses? Who remember?
Isn't it because then we can make sure that the computer always finds an answer?
Yeah, this is the idea. Yeah, exactly, Laura, thank you. This is the idea. Is there a theory in computability theory? This is the theory related to what things can resolve a computer and what things the computer cannot resolve. Let's say, okay, if you only write this type of clauses, you can say you always can affirm that the resolution algorithm, that is the program that take off these rules and try to give you an answer, this resolution algorithm always finish giving you an answer. So this is a way to guarantee that the resolution algorithm that is behind Prolog will give you always an answer. If not, we cannot affirm that always this program will finish. So this is the reason why we only use this type of rules. Okay, perfect. So this only a little review in context what we saw last day. So some examples, we did one exercise, and now we have okay, now here this is the concept of variables. We already saw that. How we write variables? How we write variables in Prolog?
With a capital letter?
Exactly. Starting with capital letter. That means that is a variable. If not, Prolog will read this word as a constant, not as a variable. So if we try to put a variable, this variable starts with capital letter. Perfect. The scope of the variable, the scope is only a line or a sentence. It's from the beginning of this sentence until the dot. This is the scope of variable. It's something that's very strange for people that usually program in other programming languages, like imperative programming languages, but it's very different way of deal with variables, the scope. For people who never programmed before, doesn't matter, that's perfect. This variable the life of this variable start at the beginning of the sentence, and finish in the dot. After this dot, variable doesn't exist. If in the next line appear another variable with the same name, is a totally different variable. That is very important to understand. Okay, we was talking about that. It's only remembering that ideas. Anonymous variable is this one. That means here that will be whatever things, but I'm not going to use. So when I want to express that here have to be something, but I'm not going to use that, I will use this anonymous variable. Okay. Next thing in our manual is this operator. This is an operator table. Here we have some basic operators. Okay. There are here an advice that is important because there are some programming languages where you need, when you are going to use a variable, you have to something like make a declaration or right at the beginning of the program, you need to say, okay, this is one variable. And you write, for example, in other programming languages, we said integer int x equal to 0. And this is a way to say, okay, this variable is an integer, it's a number, and the value at the beginning is value 0. But in Prolog, you don't need to do something like that to say before, okay, this variable this is the name of the variable, and this is the type of the variable. We only use variables. We don't need to make any reservation or declaration of variables before. Okay, and what happens if I make a mistake? If I'm writing my code, my program, I made a mistake, and here I want to write plant with n, and I write it here, this name of the variable, plant with m. This mechanism that have other programming languages to declare to describe the variable at the beginning of the code of the program is a way to say, okay, this is my variables. If if I make a mistake, I change the name of the variable, for example, string plant. this variable is a string, and at the beginning, let's say tomatoes, for example. And if I write other thing, this other programming language will tell me, okay, you make this, you don't, something like you. If in my code I make a mistake and I write plant with m equal to whatever, the program language will tell you, okay, you don't declare something like that variable plant with m, because it's a mistake. Okay, this is the one error, will be error, something like that. Something like that. But what happened in Prolog? We don't have this mechanism of detect this type of errors. We only receive this message that is like, it's not an error, it's only an advice that tell you, okay, you have one variable in one line that appear only once. Will be an error or not. If you want to write a variable only once in this line, that means that you are not going to use it, because if you write twice, there are a connection of this variable in this line. You are doing something with this variable. But if appear only one time, that means I'm not going to do nothing with this variable. It's better to write underscore symbol. That means, okay, I want to express here have to be whatever, but I'm not going to use it. So let's go to see in our programs when appears some message like this singleton variable, I have to pay attention about that and try to resolve, because this is the only way Prolog can notify us if we made a mistake writing some variable name. Okay, it's very important to take. We will see in our programs the type of messages that Prolog gives to us when we upload a new program. Okay, so this is an advice to this way to detect error in code. Perfect. Next, concept of unification probably will be one of the more important concepts we are going to see in this semester. One together with induction, mathematic induction applied to our program. But unification is something that are very powerful, and you can't find this concept in other programming languages. So for people who know how to program in other programming languages, this concept is totally new. It's not, you don't find this concept in other programming languages. So it's very important to understand how this concept of unification works. Okay, so it's very easy. The definition is use the scheme of induction. There are two parts, and base case or simple case, and one recursive case. Let's go to see what unification say. Unification say, okay, we can say two terms unify if first part, the more simple part of this definition of unification is, okay, if we don't have variables, two terms unify if terms are identical. Okay, this is a more simple case. If we don't have variables inside these terms, two terms unified if terms are exactly identical. The operator of identity is this one, is double equal. This operator in Prolog is identical. And unification, the operator in Prolog is the symbol equal. Is the symbol for unification. In Prolog, when we find this symbol, we will read unification or unify. Okay. For example, we will read x unify with 1. This is the way we read this term, unify. This is x unify with 1. And remember, in Prolog, we will make questions to the system to try to get an answer. Okay, so we read this term equal, this symbol, we will read like unify. And it's very, you will see that it's very, very different than other concept of equal when you find this symbol equal in other programming languages. Perfect. So let's go to play a little bit with this concept of, let's go to play a little bit with this concept of identity. What means that two terms are identical? Okay, one is identical to one. Let's go to as to Prolog. These terms are identical. Let's go to see what it means. Prolog say, sorry. Okay, Prolog say, yes, that's two terms are identical. Okay. This is identical to this. What do you think? These two terms are identical or not? Because the first thing we need to clarify is the term of identity, or when two terms are identical. What do you think? Do you think these two terms are identical or not?
I think not, because 1 plus 1 is not the identical to 2. No, because it's one is the formula kind of, and the other one is the
exactly
result.
Exactly. If we usually when we see this line, we automatically make a translation. Like I see here symbol plus. That means okay, this is arithmetic operation, and our brain are used to see this line, and automatically you say okay, this is the same. 1 plus 1 is equal to 2. But Prolog say, poof, that's false. Because Prolog, with this symbol of equal or double equal, don't realize or don't resolve arithmetic operations. We have another operator to do this arithmetic operation, but it's not the symbol double equal. Okay, perfect. So that is not identical. Okay, we're starting to clarify that. And that are identical. Prolog say, okay, it's true. That is true. That two terms are identical. Okay, there are 2 or 3 exceptions. So the general rule of this term of identical is try to read from left to right. For example, character to character, trying to find, okay, this is exactly the same. It's exactly the same. We're not resolving arithmetic, is only reading the left side of the part of this term of identical and the right side, and try to see that it's exactly the same with no interpretation, right? Not resolving nothing, it's only reading this line, only read this line. Okay, but we have 2 exceptions to this rule of read character by character. So what is the exception? For example, this one, what happens if I write one parenthesis here, then don't modify the structure or this term? What Prolog say? Do you think that's identical or not? Following the rule of read character by character, that is not identical, because here we have parentheses, and here I have a number one. So that is say, okay, it's not identical. It's easy to see. But Prolog say true. What happened here? Okay, what happened is internally Prolog create an structure to represent this 1 plus 1. And for Prolog, these parentheses here are not modifying at all the structure of this internal representation of 1 plus 1. So for Prolog, that is exactly the same. But what happens if I do that? Is that identical to 1 plus 1 plus 1? Are identical or not? Prolog say false. Because Prolog say that's false. That is false because internally the representation of this part of are not exactly the same of this one, because these parentheses are changing the default order or apply this operator. For example, if I write, because here with this operator we did before as from left to right, that operator is applied before, and this operator is applied in the second term. So if I change this parentheses, Prolog say that is true, because these parentheses are not changing the default structure of this term. Okay, perfect. So this is one exception. Another exception is this one. Are identical, and Prolog say, yeah, it's true. Why Prolog say that's true? Because in Prolog, every operator that will be written, it's possible to write this operator in this way, in this form, in between two terms. It's possible to write in this other way. It's like operator, parentheses, term, comma, term, and parentheses. For Prolog, that is exactly the same. It's an internal representation of this structure. So we wrote that, but Prolog is something like if we wrote that something like that, 1 plus 1, and Prolog internally write like that, like a tree, something like a tree, where we have this, something like that. And for Prolog, this internal representation of this term, that will be something like internal representation. The internal representation of this term and this term is exactly the same. It's this one, exactly the same. So at the end, Prolog say that is identical, because the internal representation of this term for Prolog are exactly the same. Okay, perfect. Okay, perfect. Now we know what is the concept of identical. Two terms are identical. In general, if we can read character by character in left and right, and we read exactly the same, with this exception of the parentheses and this way to write notation in I don't know the word in English. Okay, this notation of the symbol in between or before. Perfect. So what is the second part of induction? The second part of induction say, okay, is if we have variable, we'll try to see if the terms are identical. And the second part is if we have variables, two terms unify if it is possible to replace variables by whatever but whatever thing that will make terms identical. So this is the idea. So, or if we don't have variables, terms are identical, perfect. Or if we have variables, if it's possible to put whatever inside the variable, that at the end terms become identical. So our goal is always make this term identical. If we don't have variables directly, do we see the terms are that exactly the same, perfect, are identicals and unify. But if we have variables, two terms unify if I can replace the content, this variable, for whatever thing that at the end terms will be identical. Okay, let's go to see some examples. And remember, this is one of the most important concepts we will see in this semester, this concept of unification. Okay, for example, x unified with 1, what do you think? Yes or not? And why? We have variables there or not? For example, I want to ask you, Dina Jubisa. I don't know if the pronunciation is good.
It's okay.
This term unify or not? And why?
Honestly, I have no idea. Sorry, I really don't know.
Do you see this definition? Can you see this definition or not?
Yes, but I'm a little bit lost.
Okay, but we are at the beginning. If we are lost now, it's very important at this point to find ourselves. If not,
Yeah, I know.
so we have time. We have time to clarify ideas, and that is very important. I need your brain 100% here. Super important, because our very new concepts is very important. Your brain is here. Do you practice sometime surf, for example? Dina?
Not yet. I
No?
will.
Okay, you want to practice, no?
Yes.
Well, nice, perfect. So
I will practice.
okay, think we are surfing now. We are surfing the beach. Your brain, when you are over the wave, your brain have to be only in this present moment. You have no time to your brain to think in other you have to be only here. That's very important because these new concepts need to be concentrated. These are very simple ideas, but we need to be concentrated here. If your brain are in other things, it doesn't work, or will be more complicated. So they are very, very simple ideas, nothing complicated, and no, it's only to read. You know how to read, no? On letters. You know how to read a book. You only have to read letters and see that is exactly the same or no. It's like the game. You know this game that I have in newspaper of the differences? Find seven differences, or I don't know, what is the name? What is the name of this? You can find newspaper at the end of the newspaper, some resolve problems, like try to find the differences. No, that's the same. I'm gonna give you some two terms, and you have to tell me is exactly the same or not. This is the concept of identity or identical. So it's only see the two parts of the term, say, oh, that's true or not. So these two terms are identical, sí or no? Yes or not? Dina?
I think yes.
Identical. Identical. Are exactly the same? Do you have exactly the same in the left and in the right or not?
No.
No, no. Why? Because you have an X and you have a number 1. Are exactly the same or not?
Yes.
What do you think? Are identical? Are exactly the same? You have in the left or you have in the right or not? Prolog say no, that is false. It's not exactly the same. But what do you think? X is identical to 1? Okay, let's go to make a break. Let's go to take some minutes.
No. I think maybe someone else understand everything. Maybe
No, but
I think that the problem is in me.
Yeah, but if you are here, you have to be here. If you are here, you have to be here. If not, if you are not here, other option will be, okay, Jose, I'm not here now today. My brain is in other place. Please, I will put my attention later. I will take a look to this video when I have time, because my brain is not here. Is your brain here or not? Dina, is your brain here or not?
Yes, but
Okay, 5 minutes. Let's go to make a break, okay? Let's go to back, take a tea or whatever, coffee, and we'll back in 5 minutes. It's very important. This concept is very, very, very important. So it's very important to clarify. I'm not going to go ahead if everyone don't understand that. Okay, so, or someone tell me, okay, Jose, no problem, my brain is not here, my brain is I don't know where, thinking about my boyfriend, girlfriend, or my family, or whatever thing. My brain is not here in this case. Don't worry, doesn't matter. Later, when you have time, you can see the video again, and probably you can understand. But if your brain is here, everyone have to understand that. I'm gonna to ask you one by one, and let's go to clarify that. It's very important, this concept. If not, if you tell me, okay, Jose, my brain is not here, I have my brain in other place, doesn't matter, I will ask to the next one. That happened to me many, many times in my life. I be in the place, my brain was not there. My brain was flying. I don't know where. So doesn't matter. Doesn't matter if your brain is not here. Now it's not possible to control your brain. Okay, 5 minutes. I'm back again. Okay. One second. Okay, how are you? Luca, are you here? Everyone are here or not?
Yes.
Laura, thank you.
Yes.
Dina, Liva, are you here?
Yes, I am.
Okay, Natalia?
Yeah, I'm here.
Okay, Alexander, Noxter, are
Hello.
you here? Are you here?
Yes.
Okay, Florian.
Yes, I'm also here.
Okay, Elsa?
Yes, I'm here.
Perfect. Adriana?
Yes, I'm here.
Perfect. David?
Yes, I'm here.
Muy bien. Benjamín?
I'm here too.
And your brain too, no? You and your brain are here.
I'm not sure about my brain, but I hope so.
Okay, Milos. Zemla.
Yes, I'm here. Yes, I'm here.
Perfect, perfect. Mirna.
I'm here
And your brain?
also.
Okay. Panagiota?
Yes, I'm here.
Okay, nice. And Natalia? Natalia Sawatka? Okay. Probably is not here. She's not here. Okay, nice. Perfect. Let's go back to the idea. Now it's very important sometimes to make a break. Doesn't matter. Most important thing is I know you have a lot of experience working and taking lessons. Are very important. You're concentrate when you have something totally new. Sometimes we don't pay attention, but that breaks are very important. And if someone need to have a break, in one moment you can say, okay, Jose, please, you got to make a break. 5 minutes will be enough to change, walk a little bit, and back will be enough to take again your concentration. Okay, so it doesn't matter if someone say, okay, Jose, please, let's go to stop. That will be perfect for everyone. Probably I will try to do frequently. If I see that the many new concepts, try to make a stop. Okay, nice. Who have problems to understand the concept of identity? Let's go to start before with the concept of identical. Everyone understood what it means that two terms are identical or not? Someone have problems to understand that? No one? Okay. Let's go to put a little bit more examples about that and start and back see the second part of definition of unification. Okay, some more examples about what means that terms are identical. Well, we have some little noise. Let me 1 second, David. Okay. Perfect. Better now. If you need to open your microphone, you can do, but it's perfect. It's
Yeah,
better.
sorry, I forgot.
Don't worry, don't worry. If I detect some noise, I will be better to okay. Let's go to see more examples. So this typical example. That's false. For example, in case of list, we will see later list are identical. This list to this list. 1, 2, 3. As is true, in list, you can apply this term to many things. For example, or for example, to this predicate or a structure. It's not such a predicate, but for example, are identical or, for example, num elements the 1, 2, 3 are identical and num elements this 1, 2, 3. What people say to this question? People say it's true because only you have some structure here and Prolog say it's exactly the same. Okay, there's someone who said that you don't have you can listen to me. That's true. You can't listen to me. You have some problems with the sound. You can listen to me or not?
I can.
Yes. Okay. Okay. Probably it's a particular problem. Okay. So these two terms are identical because if we read from left to right, it are exactly the same. If I change whatever thing here, Prolog will say that's false. So we are not resolving nothing. We're only comparing these two terms and see if they are exactly the same, with the exception I told you before of this one, 2 plus 2, blah, blah, blah. That Prolog say that is true. It's a little bit strange because it's not exactly the same, but for Prolog that say that's true. Okay, second part of unification. If we don't have variables, it's just we see in this example, two terms unify if are exactly the same or identical. Okay, and if we have variables, that is a probably more complicated part. If we have variables, two terms unify if I can find wherever I can put in this variable, that will make this term identical. Okay, let's go to see some examples of this one. What do you think about that? That's unify, x unify with 1. What do you think? If we apply the definition, it is possible to put something inside the x that at the end the two terms will be identical. It's possible to find whatever to put inside x that makes these two terms identical.
Yeah, if x is 1.
Exactly. If in x I put 1, and to this question, if x unify with 1, Pro say, okay, that is true if x is equal or to 1. If unify, if I put number 1 inside. What do you think about that? Unify or not? It is possible to put something inside the x that made these two terms identical? It is possible? what I have to put inside x to make this term identical?
Well, it's the same, no? We can just put the equation, the 1 plus 1 instead of x, and then
1 plus 1. Take here into account that this operator of unification don't resolve arithmetic operation. We have another operator to resolve arithmetic operation, but it's not this symbol of operator of unification. It's other one. Okay, so it's very strange if you program in other programming languages to have to have things or something like that, because it's very strange. You saw many times that 1 plus 1 is equal to 2, but Prolog are quite different in this aspect, and 1 plus 1 unify with x and proceed. Yes, that's unify if x is equal, or you put inside x 1 plus 1. X unify with the list 1, 2, 3. It's possible to make this unification. What do you think? Yes or not? Prolog say yes, it is possible. If possible, if you inside x you write or you put one list 1, 2, 3. Okay, it's possible to unify the list with, for example, the structure num elements of the list 1, 2, 3. It's possible to replace variable x with wherever that makes these two terms identical. What do you think? Prolog say yes if x you put inside num element parentheses 1, 2, 3, list 1, 2, 3. So here we are not resolving nothing. We are only trying to find wherever I can put here to make that true. In this case, make that two terms identical. When I write something like that, at the beginning, this variable is free. Here, before the comma, the variable is free, have nothing inside. But after the process of unification, x, after the comma, here, this variable is not free. Let's go to see what happens if I ask that to Prolog. Prolog, that is true. I'm going to ask Prolog, is true that x unify with 1, comma, x unify with 2? What do you think Prolog will say? Prolog will say false. Why? Or if you prefer, pues false. Why? Because here x are a new variable, because you have to understand that a scope of the variable, the life of this variable starts here at the beginning and ends here. After the dot, the variable doesn't exist. So the life of this variable starts here, and here we say, okay, x unify with 1 plus 1. That means after the comma, x, here, x, the value is 1 plus 1. 1 plus 1 unify with 2 are identical. 1 plus 1 are identical to 2. And Prolog say that is false. Okay, this is the concept of free variable, and here the variable is not free because after the unification, the content of this variable are after that x, the value of x to make that true, we need, to make that true, we need to put inside X the 1 plus 1. And now the question is 1 plus 1 unified with 2 are identical? And Prolog say, nope, are not identical. Okay, let me see more examples here. This is similar to this example. And for example, probably one of the most strange case of this one is this is that unify. What do you think? It is possible to find something inside X that make this part of this term identical to this one? It's possible to put something inside X to make these two terms identical? What do you think?
I would say no.
You think it's not possible to find something to put inside X? Okay, Prolog say yes. It's complicated, a little bit complicated, but Prolog say, Prolog resolve that in this way. Okay, if X is equal plus 2, that will be true. Don't go ahead about that thinking. It's only, okay, if you will try a way to put X identical, or you can put inside X plus 2, could be true. It's like a recursion with no end. Something strange, but Prolog resolved in this way. That is, for Prolog, that is true. It's something a little bit strange, but and that's all. This is the concept of unification. Very, very important concept. And we have the contrary, and we have a rule with unification that say a free variable unify with wherever. You can put, if you have a free variable like X in this point, this variable is free, you can put whatever you want here, that always be true, whatever thing. Okay, in this case, no, this is an operator, it doesn't like, because it's an error of syntax error. But apart of syntax error, you can put here wherever. For example, one string, the string hola, or a constant red, or you can put whatever thing inside, if the variable, or a list, of course, or whatever. It's a free variable. You can always, you can always unify with whatever thing. You can put here operator plus, or wherever thing. Okay, perfect. And what happened with just the contrary? X, the contrary of unification is no unification. This is this symbol, it's a slash equal. This is just the no unification. What happened with no unification? It's just the contrary. So is X not unified with 1, a free variable? The contrary of all is nothing. If the variable is free, never unify with nothing. Always will be false. Whatever you write here always is false. It is very important to realize that, because it depends of sometimes in the program. I want to check something. If the variable is free, the result always be false, because the other case always be true. So the contrary of something that is always true, that is always false. So if I want to use that in more, you have to put values, not only a free variables. If you write a free variables, that is true because are not identical. One is not, don't unify with two because there are no variables and they are not identical values. But if I write X, a free variables always say that is false. That's something special idea because of this of meaning of free variables always unify with whatever thing you write. Okay. Okay. Now I'm gonna ask one by one if you understood that. Dina, did you understood?
I think yes.
Yeah. Okay. Liva,
Yes, I hope so.
any question? Any question? You have some question?
No, thanks.
Okay. Natalia.
It's okay. I understand all of it.
Okay. Perfect. Florian.
I think I have to look at it again in the video.
Okay. Nice. Perfect. Perfect. Luca.
No, I think it's clear.
Okay. Perfect. Elsa.
Probably it's clear.
Okay. Really, this is like programming computer, but it's a concept very simple. It's not exactly at this point. It's not like we're not like only talking about find differences between things. It's not really programming at this point. Okay, Adriana. It's okay.
I also understand.
Perfect. Benjamin.
Yes, I understood too.
Okay, Natalia. Natalia.
Yes, okay.
Okay, perfect. Milos.
Yes.
Perfect.
Got it.
Mirna.
Yes.
It's okay. Perfect. Panayota.
Yes, I think I'm okay.
Okay, perfect. Okay, this is a very simple idea, but very, very powerful. We will see what is the power of this concept. We can do many, many things. For example, I'm going to show you what type of things we can do with this concept of unification. It's like, for example, append is a predicate to join things. You have list one and list two, for example. 1, 2, 3, 4, 5, 6, and here we have a result. And what happen do is put everything together. Okay, it's a way to put everything together. It's first list and after that the second list. But in Prolog, a very interesting thing we can do here. We can use that in a reverse way. It's like L1, L2. And thanks to unification, Prolog will find every pair of lists that make that true, and that is thanks to unification. For example, that is true in Prolog. Say, okay, the first result is the first one, L1 is empty list, and the second one is this list. But I have more solution with this symbol. When I write this symbol in Prolog, I say into Prolog, okay, Prolog, that's perfect, but give me more solutions. And Prolog say, okay, another option if you have the list with only one and the list 2, 3, 4, 5, 6, 7. And I have more solutions. And Prolog will find for me all the solutions to make that true, to make this question true. And that is thanks to unification. And for example, you use that idea of unification here to try to find element 1, element 2, slash, and L3, L2, L2. And what Prolog do? And if I were here, this symbol would be better because Prolog will find to us every pair of consecutive elements. This is the first one, 1, 2, 2, 3, 3, 4, 4, 5, 5, 7, 5, 6, 6, 7. And now I ask, give me more. This is more solutions. At the end, Prolog say, okay, no. This false means there are no more solutions. This is the last one. At the end, we have 1, 2, 3, 4, 5, and 6 pairs, no? And here say there are no more solutions. That means this false. That means not this predicate is false. That means there are no more. What I say with this symbol, I say exist more, Prolog, exist more solutions, and Prolog say nope, there are no more. Okay, nice, perfect. There are more operators similar, or let's go to take a look at these operators here. This operator, I see this unification, x unified 1, say yes. 1 is identical, this is the old operator. To 1, and plus say true. This is the contrary, is are not identical. This is the contrary, and say that is true, are not exactly the same. And for non-unification, this is operator, and this is true. But if I leave here a free variable, always they false. But if I did, for example, something like that, x unified with 2, that means after the comma, x, the value of x is 2, and after that 2 is not identical to 1, and Prolog say that's true. That's true when x, value of x is 2. Here don't say true, because if you have a solution, that means that is true. That is true with this restriction when x is equal to 2. And here, if I have no restriction, directly write true. Okay. More operator. Operator is. The operator is the operator to create or to do arithmetic operation. And the way this operator works is realize or do the operation, arithmetic operation here, the right, and unify the result with x, with the left part of this operator. So resolve here the arithmetic operation and the result unify with x. So here the result is 2, because now the operator is, they are resolving this arithmetic in the right side of this term. Okay. So at the same time, I can put 2, because what the symbol that this operator do is resolve here and unify. So that is true. What happened if I write here 3? That is false. This next one operator is x. In this case, is similar to operator is, but in this case, what this operator do is resolve the arithmetic operation in the right part of the term, resolve this arithmetic operation in the left side of the term, and unify two terms. What happened here if we want to try to resolve an x without nothing inside, pues this is the error. That is a very common error when we are programming. That means, okay, it's not possible to resolve that because this variable have nothing inside. It's not possible to resolve because there are nothing inside, are not instantiated. Okay, instantiated. But what happened if before that I say, okay, x unify with 1 plus 1. Here, x unify with 1 plus 1. Who can tell me what we have here in x at this point? Who can tell me what we have here inside x? What do we have here inside x after this comma?
1 plus 1.
Exactly, 1 plus 1. And now this operator resolve arithmetic here in x and resolve arithmetic in the left side and the right side. And what is the result? Yes, that is true when x unify with 1 plus 1. Okay, more. Okay, the typical operator, arithmetic operator that is less than, greater than, that is false, that is true, that is true, and that is true. Minus of equal. Okay. So that is the main operators. X, you have here the explanation. Evaluate to the right, unify with the left. This operator, evaluate right and left, and unify results. And here we have a table with more operators. And what means that? Precedence. That means which part with operator we will apply before if you don't specify with parentheses. For example, this number here means that if you write this symbol, we will do before this operator, apply before that, than the other one. For example, that is related to arithmetic operation. X is 2 by 3 plus 1. What will be the result here? This precedence tells us that in case you don't write here any parentheses, will be done before the symbol plus. If we write, for example, x is 2 plus 1, 3, the result is 5. That is 3. That's operator are resolved before, because the precedents are high. Is in this case less. Number 200, 200, 400. The operator have the same number of precedents are resolved at the same time. For example, if I write 2, this is the exponential. What happened here? Have the same precedence from left to right. 2 power 1 plus 2 power 3 is 6. Okay, this table is a typical table in programming languages where you have the precedence operator table. Probably for you it's the first time you see one time with this type of tables. Okay, any question? Do you have any question? It's okay. Do you have a break? Do you have a break? Do you want a break? No, no, yes, no, it's okay. Okay, let's go to a start after unification. See this concept? Let's go to a start with the first data type, probably the most important data type. We will see the most use that very frequently, and we can resolve many exercises with lists thanks to this data type. Okay, let's go to see how lists works in Prolog. That is very useful for many type of problems. We have, for example, whatever things. List, we use list for almost everything. People in the classroom, I don't know, a list of whatever thing. How we represent lists in Prolog? It's very simple. It's parentheses. Is this symbol? How do you call this symbol? What is the name of this symbol? In Spanish, we say corchete. I don't know the word in English. What's the name for this symbol in English? How do you call this symbol? No? You don't know how to call that symbol in English? Slash. Okay. No? Luca, how do you know about, how you, in Italian, how do you call this symbol?
In Italian?
Yes.
Parentesi.
So this is a parenthesis?
Parentesi.
The same.
Parentesi quadra.
Parentesi quadra. And this one is the same or not?
Parentesi tonda.
Parentesi quadra, okay. Parentesi quadra, no?
Okay.
Okay. Okay, this symbol. And 1, 2, 3. That is a way to represent a list. And then you can, for example, if you want, you can unify this list or this with a variable list. You can do that, unification of this list. You can have, as you see in this example, leaf of many different type of things. Like, for example, you can have a list. It's possible to have a list in Prolog, like number 1, a symbol, a constant, and whatever. That is true. It's possible to work with this type of list in Prolog. There are no problem about that. X unify with that and Prolog say, sorry, list. And Prolog say, yes, why not? So Prolog know how to deal with this list of different type of elements. Okay. And it's possible at the same time to write list inside list. This is something very common also. You can do, for example, list 1, 2, comma, 2, 3, comma, whatever. And inside you write another list, another list, whatever thing. Unify with X. And Prolog say yes. So Prolog can deal with list of lists without problems. Perfect. That is a way to represent list. And here it's important to understand when you want to refer a variable list, you want to write here, for example, the variable list. You don't need to put this variable inside this bracket. Bracket, I think is the name in English. Because if you want to unify list 1, 2, 3, you don't need to represent that this variable is a list. You don't need to put this variable like this, because that means a list with only one element. And Prolog say that is false, because this list have one element and this list have 3 elements. So if you want to use a variable, only write something like that. Name of the variable, unify with the list. This is a common mistake. Try to represent a list, the name of the variable inside these brackets. Okay. Operator. Barra vertical. It's a slash, no? This operator is called a slash. Okay. This operator is very important in Prolog because it's perfect to apply induction. Let's go to see how this operator works. For example, if I want to do something like that, head, this symbol is a slash. You can use with in keyboard, Spanish keyboard is a combination of two elements here in the keyboard. Head and tail. That's unify with the list 1, 2, 3. Let's go to see what happened when we try to unify the structure of head slash tail with the list 1, 2, 3. What happened is the head is 1, the first element, and the tail is the list 2 and 3, is the rest, the tail of the list. And it's very important to realize that tail always is a list. Most extreme case will be this case. When we have only one element and nothing more, what Prolog say to this question? That unify, and Prolog say yes. Unify if head unify with 1 and tail is empty list. So we're going to use this operator many times because it's perfect to apply induction, because tail is the list without one element. This is the n-1 side of the problem for list. So this operator is perfect for us to apply induction. Nice. Any question? For example, this example here, this is whatever variable, whatever here, unify with empty list. Prolog say that is false because here in this list we need at least one element. That will be empty list, but here you need at least one element. and that it doesn't unify with empty lists that have no elements. Okay, I think will be enough for today. What do you think? I think will be enough for today, because next I have only a little bit more than 10 minutes, than 20 minutes, sorry. No, around 15 minutes. Do you have any question? This is a very, very important lesson of unification. I think that are clear for you now in your brain what is the concept of unification when we have variables and when we don't have variables. And let's go to apply many times. We are using this unification in every exercise. So it's very, very powerful. We will see, we are going to do many things with this operator, and that will help us to resolve many problems. Okay, so perfect.
I have one question.
Okay.
Will it continue to be online or will go in person?
Good question. We have to continue offline, no? There are people in Germany, Stuttgart. Who are in Stuttgart? It's not here today. Where are you? Who are not in Huelva? All of you are in Huelva or not?
Well, Florian, he was the one from Stuttgart, but I don't know about the others. But me,
All
I'm
of
in
you,
Huelva.
all of you here are in Huelva?
I am in Huelva. Yes.
What do you prefer? I'm going to cut this. Okay, I'm gonna cut this recording, and let's go to talk a little bit about that. So let's go to finish the lesson today, okay? And let's resolve that. Don't go out, please. Stay here to try to talk about that. But I'm going to say you goodbye to finish the lesson, okay? So perfect. Do you have another question related to the content of the lesson of today or not? No? Okay, nice. So see you next day. Okay, perfect. Let me 1 second to finish